Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 7.6 entitled Systems of Linear Inequalities. And today we're going to graph a system of inequalities. So that means we're going to have a line or two lines or three lines that we're going to have to graph on the same coordinate plane, and then we're also going to have to make sure if they're solid or dashed lines, and then we're going to have to shade. So this is like what we did in the past with graphing linear inequalities. You want to solve the equation for y so that it's in slope-intercept form, and then you can graph it using your slope and your intercept. And then you're going to make the line dashed or solid. Remember, if it's just less than or just greater than, that's going to be the dashed. And then if it's less than or equal to or greater than or equal to, that's going to be the solid line when it has that equal to in it. And then you're going to shade above the line if it's greater than or equal to, and you're going to shade below it if it's less than or equal to. So the only difference from what we've done in the past to today is that we're going to have two or more of those types of lines on our graph. And where those shaded regions overlap, that's going to be where our solution is. So just, a real rough example here. We might have a line that goes like that, or it's dashed, and then you're shading below it. And then you might have another line that goes like this, and it's solid, and you're shading above it. So the part that overlaps is going to be this purple part in here. That's where your solution is going to be. So that's the part that you want to darken in and consider that to be the area where any ordered pair from this region, this shaded region, will give you a true statement in both of the inequalities in the system. Okay? Now, if the regions do not overlap, then you have no solution. So that could be when you have parallel lines. Sometimes you have two parallel lines and one you shade above and one you shade below. So then there's no overlapping of them at all. Okay? So that would be an example of no solution. Okay, so let's do a couple of these just to practice them officially and see what they look like. Now, part A is meant to be very straightforward, but sometimes students forget that these are horizontal and vertical lines. Okay? Remember, if it's x equals some number, then that's vertical. X marks the spot where you stand up straight and tall. So this is going to be a vertical line. And y equals some number. Y am I laid out when I slip and fall? So that's going to be a horizontal line. So you don't have to solve much here. You just have to remember that these are horizontal and vertical lines. So the first line, x is greater than -2. So I'm going to go to -2 on the x-axis. And I'm going to draw a line through it, but I want a dashed line because it's just greater than. So I'm going to have my dashed line going through the x-axis or across it. And then I'm going to shade everything to the right. And just for now, I'm just going to put a little note that I'm down here that I'm going to shade to the right because I don't want to cover up my graph too much until I get my other line drawn in there as well. So I'll switch colors here, and y is less than or equal to 4. So I'm going to go to 1, 2, 3, 4 on the y-axis. And this had the equal to, so this is going to be a solid line that goes across here, goes across the y-axis. And it's less than, so I'm going to shade below. Okay, so now the region that gets shaded twice, okay, here I can shade a little bit more for everything. Okay, so I was going to shade everything to the right of the dashed line, so that's over here. Everything over here would get shaded. And then everything below the green line, so everything below the green line would get shaded. So now you can see the part that got shaded twice is this part right in here. It's the bottom right area that's formed by the graph. So that's the spot where the shaded regions overlap. That's my solution for both inequalities. That's the part that you want to darken in on your graph. Now, as you do more and more of these, you'll be able to just do the part where it's shaded. So for now, as you're learning, if you want to shade in all of one region and all of the other, and then darken in where the overlap is, that's fine. As you get more sophisticated, if you just want to shade where the overlap is, that's totally fine too. Okay, so let's do one more here with just two equations. Let's see. Now for this first equation, I'm going to have to solve it for y. And to do that, I'm going to have to add the x over to the other side. So that will be y is greater than x minus 5. Okay, so I'm going to graph that. So we go to negative 1, 2, 3, 4, 5. And then my slope is 1. So I'm going to go up 1 and over 1. And then down 1 and back 1. And I want a dashed line to connect those. And then it was greater than, so I'm going to shade everything above. So for now, I'm just going to put a little notation that I'm going to shade above it. Now this other equation I'm going to have to do a little more work for. I'm going to have to subtract the 4x so that I get the y more by itself. And then I'm going to have to divide by 3. So I'll have negative 4/3 x plus 2. So I'm going to start at 2 for my intercept, and I'm going to go down 4 and over 3. Down 4 and over 3. And I want a solid line to connect these. I'm going to make my solid line. Now, in the past, we wanted the ordered pair where the lines crossed. And these lines do cross at a nice ordered pair, but that's not going to be my only solution. Okay? So I'm not going to write down that ordered pair today. I'm going to shade. And for that green line, it was less than or equal to, so I was going to shade everything below that line. Okay? So again, let me shade everything here. I'm going to shade everything below the green line. And when you do this on your homework, you might want to do it kind of light at first. And I was going to shade everything above the blue line. Okay, so now I can see where it overlaps. So the region that gets shaded twice is over here. It's kind of off to the left. So it's in between that dash blue and the solid green line and to the left. So that's the region where my answers are going to come from. Any ordered pair in this red region will give me a true statement when I plug it into either the blue or the green equation. Okay. So now let's step it up a notch and let's do a few that have 3 lines. And you might see a few of these on your homework. These are just good ones to practice, just to show that you really have mastered the skill of graphing and shading. And notice that in part C, we have 2 lines that are horizontal and vertical. Okay, so don't be overwhelmed by this. So the first line I'll make blue. That's going to be vertical. So I'm going to go to 4 on my x-axis. I want a dashed line, so I'm going to do my vertical dashed line through 4. And I want to shade everything less than 4. So remember, on vertical lines, it's either to the left or the right. So less than would be to the left. So this is where it's good to just kind of make a little note for now as to what side you're going to shade on. My second line I'll do in green. This is y equals, so it's going to be horizontal. So I'm going to go to negative 3 on the y-axis. And I want a solid horizontal line that goes through it. And it was oh, it was greater than, so I'm going to shade above. And then the other line, let me do that in purple. This one I have to solve for y. So x minus y is greater than or equal to 4. So I'd subtract the x. So negative y is greater than or equal to negative x plus 4. And then I had to divide everything by negative 1. Now remember, with inequalities, when you divide by a negative number, you switch that inequality sign around. So I'll have y is less than or equal to x minus 4. So my intercept is going to be negative 4. And then I'm going to go up 1 and over 1. Now again, it touches the green line and it touches the blue line, but I'm not really concerned about those ordered pairs where it intersects. Okay? And I've got a solid line here again to connect those. Okay. And then I would want to shade below that. Okay? Now, this is a really small triangle that forms. Most of the time you're going to shade inside that shape that forms. But let's double check our shading here. This blue line I was supposed to shade to the left, so that would be inside the triangle. The green line I was supposed to shade above, and the purple line I was supposed to shade below. So yeah, everything inside this triangle is where my solutions will be. So this is a good example where you might not want to shade the entire graph 3 times and then darken in the overlapped part. This is a good example where you just want to shade the part that's supposed to be darkened in or overlapped. Okay, now for part D, I've got 3 equations here. So let's do the top one in blue here. And neither of them are horizontal or vertical. None of them are solved for y. So we've got a little bit of work here that we have to do. So for this first equation, I'm going to have to subtract the x over. So negative x plus 3. And then I'm going to divide everything by negative 2. So that's going to flip my sign. Now negative 1 divided by negative 2, remember that's 1/2. And then I'm actually going to get, oh my goodness, negative 3/2. I get a fraction? Yep, sometimes you do. Now remember, negative 3/2, that's 1/2. So I'm going to graph that. I'm going to go down to 1/2. And then my slope is up 1 and over 2. So I've got to stay at those little halves when I'm graphing this. So you can still graph it. It's just kind of irritating to go down a whole unit and back 2 whole units. Down a whole and back 2. Down a whole unit and back 2. So you're staying at that halfway mark the whole time. And we want a dashed line to connect them. And then it was greater than, so I want to shade above. Okay, my second line here, the green line, I'm going to have to subtract the 3x, so that'll be 2y is greater than negative 3x plus 9. And I'm going to have to divide everything by 2. So negative 3/2 x plus 9/2. Oh my goodness, more irritating fractions. But again, remember 9/2, that's 4.5. So I'm going to go up to 1, 2, 3, 4.5. And then I'm going to go down 3 whole units and over 2. Down 3 whole units and over 2. So this problem is more challenging not only because we've got 3 lines, but it's also more challenging, whoops, 1, 2, 3, over 2, because we've got these fractions that we have to deal with. But it's good practice. So I want a dashed line, and it was greater than, so I want to shade above the line, so that would be on this side. Okay, now my other line, do that in purple. To solve this one for y, I just have to subtract the x. So y is going to be less than negative x plus 6. Whew, this one doesn't have any crazy fractions. So I'm going to start at 1, 2, 3, 4, 5, 6 for my intercept. And I'm going to go down 1 and over 1. So this is another good time to point out that sometimes these lines don't always cross at nice, neat points. Okay. And here again, I want another dashed line. Wow, we didn't have any solid lines for this one. That's pretty crazy too. Okay, so my purple line is graphed now. I want to shade below it. Okay. So again, this is where it will get kind of messy if you try to shade for all three regions. So let's just try and visualize where that overlapping part is going to be. And you can see my triangle kind of formed in here. So that's probably where we're going to shade. So let's double check. I'm going to shade above the blue line. Okay. I'm going to shade below the purple line and above the green line. Yep. So definitely inside this little sliver right here. It's a very funky shape. Okay. And probably maybe goes up a little bit higher, but it's kind of hard to see with my lines there how far up it would actually go. So that problem is kind of a beast, but if you understand it, you can do it, you're good to go. Okay, we've got two more examples. Example 2 now, we're going to reverse the process. So we're going to write a system of linear inequalities for this shaded region. Now, I will admit that the shaded region might be a little hard to see exactly where the lines are, so we might have to kind of draw in some of these other lines if need be. Okay, so there's our axes, okay, but I didn't want to cover it up too much because I want you to see that shaded region and where it is. Okay, so this is my y-axis and this is my x-axis. So this line right here, that's a nice horizontal line, and that's easy to tell that that's at -2. So if it's horizontal, it's going to be y equals something. It was at -2. And it was a dashed line, so it's either going to be less than or greater than. And it's shaded above, so it's going to be greater than -2. Okay, so there's one of my equations in the system. The other line is down here. It's slanted, so it has a slope. So we can do slope-intercept form with this one. So it looks like my y-intercept is right there, and that would be up 1, 2, 3, 4 units. And then it looks like another nice point. Well, let's see, right there. That's another nice point because it's right on the x-axis. So that looks like I would go down 1, 2, 3, 4, and over 2. So I'd go over 2 and down 4 for my slope there. So let's see, it's going to be y. And my slope, let me make a little note over here. We said it was down 4 and over 2. So that would reduce to -2x. And my intercept, we said, was 0, 4. So that would be a +4. Now this is a solid line, so it's either going to be greater than or equal to or less than or equal to. So we're going to have some kind of equal to in there. And it looks like we're shading below the line. We're shading down this way. So we're shading below the line, so that would be a less than. Okay, so that would be the system of equations for this graph. So you're going to have a couple homework problems like this where you have to kind of work backwards, but this is a good skill to definitely master. Okay, one last one then. Whoops, I guess it's right here. There it is. Is going to be a word problem. So again, we're going to have to write the system and then solve it. And again, this is going to be a system of inequalities. Okay, and here we have two vehicles. One takes regular gas and the other takes premium. So according to your budget, you can pay no more than $90 for gas. Okay, now these gas prices are a little high. Gas prices have come back down again, thankfully. But let's just say that the regular gas costs $3.05 per gallon and the premium gas costs $3.15 per gallon. So if the two vehicles can hold a total of 29 gallons of gas, how much gas can you get for each one without going over your budget? Okay. So again, we've seen these word problems the whole chapter now. Remember, we have, in this case, we have a money equation and then we have a thing equation. Okay. So we definitely have some money here. We have 305, we have 315, we have 90. Okay, so there's our money stuff. So the 305, that was for the regular gas. And then the 315, that was for the premium gas. And then altogether, I can't go over $90. It says you can spend no more than. So you could spend equal to 90, but not more than it. So we want less than or equal to 90. Okay, so that's our equation for our money. Then we also have our things. And in this case, our things would be the gallons. Okay, we have 29 gallons of gas for both vehicles. So however many of the regular gallons plus however many of the premium gallons, we can't go over 29 gallons. So again, we have to be less than or equal to 29. You can't go over it because if you go over 29 gallons, then your car tank, the gas tank is going to overflow. Okay, so we got to stay under the 29 gallons. So now, if I'm solving this, I could do elimination. I could multiply everything in the bottom by a negative 3.05 or a negative 3.15. But then you're going to have some crazy decimals. Okay. So I'm going to do substitution on this one. I'm still going to get some crazy decimals, but I'm not going to have to do as much multiplying with them, I don't think. Okay? And I'm just going to solve this equation for r. Now, when I solve it for r and I do my substitution, I'm just going to think of it, whoops, like an equation for right now, just temporarily. So if I solve that for r, I'm just going to subtract, oh, what's going on? I'm going to subtract the p over. So I'll have 29 minus p. Okay, so that's the equation that I'm going to substitute back into the top equation. Remember, I have to put it into the other equation. Don't put it into itself. That's like plugging Christmas lights into itself. Okay, so then I will have, let's write it over here, I'll have 3.05 times, instead of r, I'm going to write what r is now. R is 29 minus p. And then I'll have the 3.15p. And I'm going to leave the inequality here for now, less than or equal to 90. Okay, and now I do have to distribute, but I really only have one nasty calculation now where I have to multiply by a decimal. So we'll use our calculator for that. You should get 88.45 minus the 3.05p. So that was really easy to multiply that by 1. And then I have the 3.15p and then the 90. And then I'm going to combine my like terms. So I'm going to combine the 3.15 and the negative 3.05. So that would be 88.45. And then that's going to be what, a 10-cent difference there? So plus 0.10p. And then I'm going to subtract the 8845 over to the other side. Remember, when we're dealing with inequalities, we like to keep the variable on the left side of the inequality. So 90 minus 8845, that's $1.55. And then if I divide by the 0.10, I'm going to have 15.5. Okay, and that 15.5, remember, that's the number of premium gallons of gas that we can get. So we can get 15.5 gallons or less. Now altogether I had 29 gallons. So my last little step here then is going to be to do the 29 minus the 15.5. And that's going to be the 13.5. So then for the regular, I could get less than or equal to 13.5. I want it to be less than or equal to because I can't go over that 29 maximum. That's my max. I have to stay below the 29 gallons. Okay? So I'm going to stay below 13.5 and below 15.5. So I could buy any combination as long as I don't go over 15.5 gallons of the premium and I don't go over 13.5 gallons of the regular. Okay? So I could buy, I don't know, 12 gallons of the premium and 2 gallons of the regular, and I would still be under budget. I would be under my $90 budget. Okay? So, whoops, went too far. So this is your homework for tonight to practice these concepts. Definitely make sure you have some graph paper. You will be doing some graphing, and you can still do substitution and elimination with these as well. But since it's shading, there's a lot more graphing that you do with these. And remember, if the shaded regions don't overlap, then it's no solution. So if you have any questions on this, come on in and see me before school.